So this is my work in progress physics engine for two-dimensional games. Um, this is actually the final phase of correct collision detection using something called sweep and prune, which is a broad-phase algorithm used to detect collision. Um, it's also used to limit the number of pairs of solids that need to be checked for collision. So, for example, intersections. It's achieved by sorting the starts, the lower bounds, and the ends, the upper bounds of bounding volumes. In this particular case, I have set up boxes, so I am using axes-aligned bounding boxes. Um, these are set up along a number of arbitrary axes. So specifically in the two-dimensional case, I have it set up between the x and y axes. As the solid moves, their starts and ends may overlap. I haven't actually improved the overlapping algorithm, but when they do overlap on all the axes, they're flagged to be tested by a much more precise and time-consuming algorithm. Essentially how it works is I'm exploiting temporal coherence. So, for example, we insert a box here, and we can insert another one, and you notice that there is some restitution involved. The boxes do bounce. As the height starts to get less and less, the restitution obviously is going to become less and less because there isn't enough time to pick up velocity. So we're just going to make this tower tumble. And mind the slowness factor of this. So as you can see, there is some bugs present, particularly this box is sitting absolutely on nothing. There's some overlapping problems. That's because I haven't actually implemented any sort of more precise detection. This is just plain exploiting of temporal coherence. So it's not to be used. It's not to be used as is. The configuration of physical bodies in this particular case from one time to the next changes very little. So many of the objects may not move at all. So I designed the algorithm so that the calculations done in a preceding time step can be reused in the current time step, resulting in faster calculation. It's what allows this to actually be possible and efficient. Each box is represented by the product of three intervals. So a box would be I1 times I2 times I3 equals A1 B1 times A2 B2 times A3 B3. So the algorithm being used here is just sweep and prune. We observe that two such boxes intersect if and only if all three boxes intersect. So we suppose from one time to the next, ik and jk intersect, then it's very likely that the next step they will still intersect. Likewise, if they did not intersect in the previous time step, they are very likely to continue not to. So by exploiting that factor, you can actually make this a lot more efficient than what it actually is. But because it's an exploit of temporal coherence, it's not as precise as it could be. As you can see, there's still overlapping. There's things that are not exactly correct in this particular case. Let's go ahead and clear that and close this window. You're probably going to see part of my editor here. What I'm going to do is I'm going to increase the restitution of this to about half, and I'm going to recompile. And you're going to see that despite being able to change very specific definitions for density, friction, restitution, the algorithm still works the same. So as you notice, the boxes are bouncing higher than before because there's higher restitution. But you'll notice that if this starts to happen right here, where if a box is in mid-flight and another box hits it when restitution is enabled, what happens is temporal coherence doesn't take effect because the object needs to be in a static state in order for you to actually calculate the sweep and the prune for the next object that's going to hit it. And because that doesn't happen, what what essentially occurs is the velocity of the object that it hits increases, and it causes something called a jittering artifact within the physics engine itself, and that causes these sorts of things to happen where boxes themselves are actually sitting where they shouldn't be sitting. Like this particular box, for example, should be sitting on the ground, but it's not, because during the actual physics step during the physics step, when the box hit it, it hit the ground and it bounced up, and because temporal coherence kicked in at that static stage when it hit the ground, the restitution brought it up, and it thinks it's sitting on a box, but it's not actually sitting on a box. It's sitting higher than what it should be. It thinks it's the ground, or it thinks it's on a box, but that box is not there, because again, temporal coherence doesn't take effect until the physics steps take effect, which only take effect at a specific interval. And those intervals are completely dependent on the actual positions of the boxes themselves. This can be improved much further, but it's hard to do it within logarithmic time. But I do intend to add more precise algorithms in the future. This is more like a optimizational step. And once I do actually implement a more precise method, it'll actually look a lot nicer.